Hi, now we will talk about another question, which is question number 3, page number 2. We have a hoop with mass 2.7 kilograms. This is question number 3. And it's rotating. You need to be careful about that. It rotates with omega is equal to, the rotation speed is 320 round per minute. This round per minute is round per minute. Okay, you know that it will rotate 320 times in a minute. Okay, we need to find omega in radians per second. We can write omega is equal to 3. It is a different unit. Okay, we need to know that 1 round is equal to 2 pi radians. This is 1 pi radian. This is 2 pi. This is equal to 1 round. So 1 is equal, if we divide the both side over 1 round, 1 is equal to 2 pi radians divided over 1 round. This is equal to 1 because this term and this term are equal. Also, 1 minute is equal to 60 seconds. So 1 is equal to 60 seconds over 1 minute. We need these coefficients to convert the units. So omega is equal to 320 round per minute. I multiply here by 1, which is 2 pi radian over 1 round. The minute, I multiply it by 1, which is 60 seconds over 1 minute. Just I can cancel these units. And I have 2 pi, 60. The value will be 320, 2 pi from here over 60 radians per second. This will be equal to 33.5 radians per second. This is my omega. If the radius is 0.323 meters, that means it is, give me this one, please. Yes. 23 centimeters from here to where? To here. This is 23 centimeters. This is the radius of the hoop. That means that diameter is twice. It means it is twice. Okay. What is the tangential velocity? If this hoop is rotating and go around like this, it has angular velocity, which is omega, and if it is going like this, sorry, where is the cut? This is the cut. If omega is rotating, then, and we have tangential velocity, then it has linear velocity also, v. V is equal to r multiplied by omega, which is equal to 7.7 meters per second. Okay. Now, what else we need? We know that r is given, the mass is given, this is the hoop. We need to find the moment of inertia, which is mr squared for the hoop. You will be given these quantities, these formulas. mr squared, then the moment of inertia, which is the effective mass in rotational motion, which is equal to 0.1428 kilogram meter squared. Now, if we have motion, then we have a kinetic energy. We have two more kind of motions. Now, we have rotational motion and we have linear motion. We need to find in D and E the rotational kinetic energy and the linear kinetic energy. So we need to use the linear kinetic energy formula in the linear motion and the angular kinetic energy formula in rotational motion. So I use the moment of inertia multiplied by omega squared, which is equal to approximately 80. You will see that we need to approximate, and the linear kinetic energy is equal to 1/2 m multiplied by v squared. We know how much m, and we know v also. This will give us 80 joules also. We have 80 joules as a rotational kinetic energy, and we have 80 joules as a linear kinetic energy. Add them together to find the F requirement, which is the total kinetic energy, which is approximately 160 joules. It is easy. Just you need to look at this problem. If we give you this question, and you have 1, 2, 3, 4, 5, 6. Yes, 6 requirements. If you look at all of them at once, you will find this question is difficult. But when you are solving them part by part, it will be more easy. Try that by yourself. Thank you.